I'd like to continue where Win actually ended with his presentation, where he said, well, for PLS, we need a different narrative. We don't need to just use the factor-based vocabulary, jargon, and so on, and just say PLS is almost like factor analysis, but just not as good. And that's the argument that Ed made in his 2012 article. And I would like to contribute to that and starting to develop this narrative of where PLS really ties in and can also, for confirmatory purposes, really provide an added value. We saw before, well, Win discarded the idea, well, fit is not really important, shouldn't really look at it. Well, in the types of research questions that Win looks at, I would completely agree. I would not agree that fit in general doesn't play any role. It's also a useful concept that can help us to develop science further. And I would like to make the point for using PLS to conduct a confirmatory composite analysis. First, to give a bit of a background, I just recently moved position and came to an engineering faculty. And I'm so to say a bit of an enclave, a marketing instructor within a design school. Actually, I teach design engineers to make them more market-oriented when they develop products. But what turned out, well, all my colleagues are designers, and I'm the only one coming from more social science, business science background, and I found out they do a completely different way of research. And that was really astonishing. I wanted to learn more about design. I'll say, well, why do they do things different? And is it just bad research, or are they just not yet up to all the methods that have been developed in social science and psychometrics, econometrics, and so on? Or what is going on there? So first I visualized, well, design is actually a very, well, old science, well, in particular old practice. So we can go back really to the, well, starts of mankind. Well, as soon as artifacts were made, we can speak of design, as design being, well, the creation of artifacts for a purpose. And we see that design really plays large importance in many places of our lives, because design really influences, well, everything around us, and the architecture, the sound we hear, the furnitures we're using, and so on, the technique we're using. Well, all has been designed. So it's a highly relevant field for our daily lives. So it seems to be astonishing then that, well, in all these fields, they haven't been using the, let's say, strongly developed techniques of social and business science. Now, in my endeavor to get a further understanding of what design is, I came across some quotes that really describe it nicely, and it all ties back that you create an artifact for purpose. Here are two quotes from two designers, Charles Eames and Shimon Shmueli. I don't know whether he's related to you, it could be. Now, in any case, first quote is, design is a plan for arranging elements in such a way as best to accomplish a particular purpose. Again, putting elements in some way together for a certain purpose. Or design is art optimized to meet objectives. So this is the core essence of what design is, and that's also reflected in more formal definitions of associations related to design. For instance, this is the accreditation board for engineering technology. It's a board created by all the engineering associations of the US IEEE, the Mechanical Engineering Association, and so forth. And they agreed that engineering design is the process of devising a system, component, or process, and so on, to meet desired needs. One sees already the purpose in there. Or more particular, well, they refer to a stated objective as a definitory part of design. Now this is interesting and can then lead also to models and testable models. But first we should visualize that design research is different from, well, the usual research we find in business and social sciences. And that has to do with one very simple thing. Well, in most times when we use structural equation modeling, what we want to do is we want to find out, is our model true? Have we found an explanation for the mechanism how the world looks like? Or have we found that mechanism that explains the world? That's what is often striving for. In design research, this question, is it true, is completely irrelevant, because they just create the truth. They just make the things. And when you make it, it's there, per definition. So the whole research question that we all about, well, doesn't seem to be relevant for them, and that's also an explanation why the methods seem not to be useful, at least not in the first place. And there are some endeavors to cope with the situation of design research, because design researchers face a large disadvantage, particularly in those disciplines where you have both a social science orientation and design orientation. For instance, in information systems or marketing, some researchers create things, create artifacts, create strategies, create instruments. They are actually doing design research, and others are then looking at, well, how do these artifacts interact with an environment? Well, and this is classically observing positivist research, as we are most familiar with, I guess. So these design researchers feel having a disadvantage because they don't get their papers published. Editors, reviewers ask them, where's the analysis, where's the fit measure? And, well, they must say, well, we haven't. It's just not there. And one approach that then these design researchers coping with this disadvantage follow is, well, let's write a pamphlet. And also say, well, design research should be published anyway, no matter whether it has fit measures or not. That's, for instance, this trial here in European Journal of Information Systems. They say, well, our research is different, but please publish it. Okay, that's one approach, but I think that's not really what one should strive for, but rather develop that part of science. And I believe that design research is a larger part of science as we actually might think of. Just like many of you are also in marketing, all these constructs like a marketing mix, a portfolio, a system, products, strategies, these are artifacts. And this is nothing given by nature, where we would like to find what is the underlying factor, but it's created by men or women. So always when we have artifacts, then well, it doesn't make sense to use factor analysis, but it might make sense then to use a sort of composite analysis. That's one way to look at it. Another issue is that, as I said, the logic is different in design research and more positivist research paradigm used in social and business science. Namely, in positivist research, we have two ways of argumentative reasoning, which is induction and deduction. Deduction, deriving theory from existing theories, and induction, well, learning from the empirical data and testing. But in design research, you have a third way of reasoning, which is abduction. And the reasoning of abduction is simply, if you have a problem Y, solve it through a design X. And this is different, and we can see that this way of reasoning cannot be traced back to these other forms of reasoning. So it's the third way of scientific reasoning. And if we're able to incorporate this in our models, which with covariance-based factor analysis or structural equation modeling is not that easy to do, if at all, then well, we can provide value. And let's look at this a bit more, this abduction, which is actually the cornerstone of pragmatism. Well, pragmatism means you create an artifact out of several resources, elements, or whatever, and this artifact is based within well, a wider nomological net, namely of its antecedents and consequences. So there are reasons why this artifact is there, and there is also, well, it has its consequence out there in the world. And well, when we look at this, well, it looks a bit like a structural equation modeling, doesn't it? With these concepts in there, the paths, the arrows drawn there, so it looks familiar. But in fact, it's slightly more complex than that, because what we need is a sort of theory for that we could test here. And when we ask psychometrists, does the composite model, is it testable? We would say no, because you can create the weights as you want. But it gets interesting as soon as the composite is included in a wider context. then one can test whether it's really the artifact, the whole, which has certain effects in the wider context, or whether it's the ingredients. And that then is what my suggestion should be one of the central questions that one should ask in all types of design research. Whereas in psychology, sociology, and so on, the major question is, does this factor exist? One hypothesized that there is an underlying factor explaining why we have certain levels of the indicators. For design research, the major question is it what we have designed what really creates these effects and which plays a role in the world, or is it just the ingredients? Because if I've just picked good ingredients, it's just applied research. It has been shown that these ingredients are useful in context A, I apply them to context B, and that's it. But a designer and a design researcher, it's not about applied research. Although they very often believe that they just apply principles from physics and so on. But no, it's a different game. Well, if you want to call it a game, it's different rules and different things that they want to do. In fact, it's about they create something new, and this new plays a role in the world. So we need then to test that the whole is greater than the sum of its parts. And the idea can be simply visualized by these parts. We have a rhomb, a triangle. We can compose them in several ways, and there are some ways how we can combine them. Maybe this not, but maybe if we combine them in that way, and suddenly the whole out of these two components has a different meaning. And it's then this meaning what we are interested in, and not what these two elements do. So the major question is then, have we created something which has this additional meaning, where really the whole plays a role and not the simple ingredients? In this case here, it was very simple, because what we created was an artifact which resembles to something which we already know from the world, a fish. So there we can just check, okay, is the artifact that we have the same as something which already exists? And now design research makes it a bit more complicated, because designers want to create things which do not yet exist. And then the simple thing that we did here, the heuristics, just to check, do we know what we see, and does it form a whole, doesn't work. You need a different way of examining whether indeed the whole plays a role and not the elements. And that's in fact a question that we also should ask in marketing and other disciplines. Is it really the marketing mix that leads to success and what we should teach our students, or is it every single instrument? And if it's every single instrument, well, we should not bother about introducing the marketing mix, because it's a completely irrelevant concept and it just fills textbook pages without any additional value. So the question is it worth having this, this new entity and bring it forward in science? That's something that needs to be explained and needs to be investigated. And interesting, if you ask this question, is the whole more than the sum of its parts, we can test it. Because a model where the whole is more than the sum of its parts is different to a model where this is not the case. And we find these two models here. The first model above is where we have, let's say, now only 3 parts. These parts form a new concept, and this concept is embedded in a nomological net. And for the ease of sake, well, let's say we have 2 consequences. We will see that the nomological net, it needs more than just one consequence. That is not sufficient, but if we have 2, or we have 1 antecedent, 1 consequence, or 2 antecedents, well, a sufficient number or sufficient amount of context helps us to investigate our phenomenon of interest. So this is the first model where we say it's the concept C which plays a role in the world and not the parts. Whereas the alternative view is, well, we have these 3 parts, they influence these, or they have these consequences, and we can look at them together and call them concept C because they are grouped together, but in fact it's not the composite which has these, plays the role in the world, but it's the simple ingredients. And as you can see, these 2 models differ in the amount of parameters. Here we have 5 arrows, here we have 6 arrows, and that tells us already, well, we have a difference in the degrees of freedom. And we can test whether this model doesn't have a significant worse fit than that one. It will always have a worse fit, because you have fewer parameters available which are free. But the question is the fit significantly worse? It's the same question that we know from confirmatory factor analysis, where we do this comparison and we derive whether a factor actually exists or not. And here it can help us to answer this question: is the whole more than the sum of its parts? A very classical saying from actually Aristotle more than 2,000 years ago. We can a bit more technically look at the implied correlations, and the implied correlations confirm our notion of parameters that are free. For instance, when we look at the implied correlation matrix, it's reduced to the relevant elements. We see that in this model, which contains the composite, well, we just need 5 parameters in these 5 correlations, whereas we say it's the independent elements which play a role. Well, we need 6 different parameters. So the question is now, how can we combine these all these things? How can we combine the 3 ways of logical reasoning and well, put it all together that we can do this kind of research to find out whether the whole is more than the sum of its parts? And the idea is here, let's use confirmatory composite analysis. And it's a relatively newly introduced term that Theo Dijkstra and I and a whole other group of researchers introduced in 2014 to test whether really a model containing this composite has a certain fit. And this confirmatory composite analysis consists of 3 steps. The first step is to find a technological rule, well, actually a weighting scheme as its simplest form to create the composite. And this is, in terms of scientific reasoning, it's abduction. It means if you want to have this concept, you should create it in that way. So we need to have a prescription of how to create this composite. Then we can come to the deductive step, namely we need a context. We need a nomological net in which this composite is placed, otherwise we can't test whether it exists or whether it contributes to the world. So that's deduction deriving from extant theories, the nomological net. And the third point is then, classically, statistical inference. That means empirical research that lets us estimate the model parameters and assess the model fit, so that, well, a classical form of inductive reasoning. All these 3 steps are contained in confirmatory composite analysis. So here we see, for instance, how this abductive step can be filled in. It can be, well, it firstly means what are the elements. That's, of course, a choice that the design researcher has to make. And then one can use different weights. One can predefine the weights. One can set them equal, or one can use several techniques, like, for instance, PLS, Jessica, and many others, to determine the weights that the composite is created in a way that it fulfills its function optimally within this nomological net. So all of them are scientifically defendable, but later then empirical research needs to show whether the technological rule, the weighting, indeed makes sense. The deductive step is then coming up with other concepts in the model to which this concept can be related. And I'll skip this. If we have established certain model, like for instance this one here, well, one can show that it's equivalent to that one if one would like to draw in that way. One would get an implied correlation matrix, which was already shown by Ed and Theo actually. This is just another way of writing down, where we have unrestricted correlations between the indicators of one construct, so it's just the empirical correlation, but only the correlations between indicators of different concepts, they are constrained to these terms. Good. In this inductive step, we can use limited information approaches, like for instance, principal component analysis and ordinary squares multiple regression, as was also illustrated by Wing. We can use partially squares path modeling, which also is limited information estimator, because one part in the model is not influenced by a very far away part of the model. So if there is a model misspecification, at least the rest of the model is not that much affected. There are also full information approaches who say, no, we rather want to integrate all available knowledge at all places in the model and then get estimates. Then we have this inductive step of testing the model. And here, for this type of research question, the fit is essential. Is our model that we have created, does this differ significantly from the world? So this is the most central question. This is this p-value we know from confirmatory factor analysis. This is the fit measure that editors and reviewers, for some research questions, some contributions, definitely correctly ask for. For others, they just ask for it and don't know why. But for sometimes, and in this case here, it's really important to analyze the fit. How can we do that? We can use approximate measures of fit, like for instance the SRMR, which was introduced by Hu and Bendler, or we can even use exact measures of exact fit. Measures of exact fit that provide a p-value, or at least let us make this inference by means of confidence intervals. How probable is it that the model is actually wrong? And one can, for instance, use the geodesic distance function between the empirical and the implied covariance matrix, or why not also the maximum likelihood one. They all can be applied. That's what Theo showed yesterday, and we'll see that some of them even have been implemented in software, as we see later. We do a very small simulation study, find out can indeed confirmatory composite analysis distinguish between correct models and models that are misspecified. Does it do its job? Do the tests work? And it's a very preliminary study, only a very small number of replications and data sets. But let's start with it. Let's say we have a model like this. A researcher believes there are two concepts, both are composites and they are related. This is the way what the researcher believes, and the model what the researcher starts with analyzing, because the researcher doesn't know how the world really looks like. Let's start like that. And then say, okay, in a Monte Carlo simulation we can create the world as we like it to be, and so first we're very fair. We create the world indeed like the researcher believes that it is. So we have here some weights, some correlations between these indicators. This is the way how the composites are then created, and they're to some degree interrelated. So that's the truth. Then we get a bit mean and say, now the world is different than what the researcher believed. Actually, this indicator contributes to that concept, and this indicator contributes to that one. And another way how we are mean, we say, well, there is some additional correlation between A3 and B1 for whatever reason. Maybe if it's questionnaire based, maybe they're both reverse question, and for that have some technical reason to be, also response style reason to be correlated. Whatever, it could be. But definitely then the model that the researcher estimates is not the correct model. So let's look at the fit results. Well, when we look at the population model 1, where really the model that the researcher estimates is in line with the true model, then we find that the test based on the geodesic or maximum likelihood distance between the empirical and the implied correlation matrix is 4%. Well, we accept 5%, that's our p-value to make our threshold, so 4% is excellent. And we get an approximate measure on average of 0.0393. When we look to the wrong models, or the case where the researcher estimated the wrong model because the population model was different, we see that, well, our test quite reliably rejects this model, telling the researcher, your model is wrong. And also the average SRMR is much higher. It's definitely above this commonly reported threshold of 0.08. So it seems that even this threshold of 0.08 doesn't seem too strange in the context of confirmatory composite analysis. And then the second and final study wants also to see whether confirmatory composite analysis can find misspecification in the structural model. And again, a researcher believes that this is the way how the world looks like. One can combine three concepts in that way. All of them have three indicators and are composed of those. And firstly, we create a world which is indeed like this. similar measurement models, relations of 0.3. And then again we get somewhat mean and say, no, the truth is there's also this path of 0.5 which the researcher had forgotten to include, or there was no theory for it, well, whatever reason. So the model that the researcher estimates is definitely then wrong, because this is the way how the world looks like. When we look at the statistical test, and we see that the correct model, well, it's hardly ever rejected. In both cases we see less than 5% rejection for these types of model, and we find a mean SRMR of 0.594. And this tells already, well, the SRMR should probably not be a 0.05, well, because then we very often would reject the true model. So probably 0.808 is not that bad, although it's always, well, only a rule of thumb. And the more precise test is the exact test, and we see here that it clearly rejects the wrong model and pinpoints then this analyst that, well, one should look for other explanations. And I like this very quote that we had, where it said, well, what does a significant ill fit mean? Well, it means that there is more information in the data than was covered by the model. And so maybe we can do something with this information. So conclusion that we can draw out of these things is, first, see that design research at the current situation lacks empirical methodology. And with design research, I do not only mean the research of fashion designers, product designers, and so on, but I also mean the research work of design researchers in business and social science disciplines, whether it's social design, organizational design, systems design, or whatever. Confirmatory composite analysis can help here to test for emergence, test for this concept whether the whole is more than the sum of its parts, and is therefore really parallel to confirmatory factor analysis, where the existence of a factor gets some support, and here the usefulness of a concept that is created of elements gets empirical support. Technically, confirmatory composite analysis combines variance-based structural equation modeling and model testing, actually bootstrap-based. And for those who saw the formally, well, it's actually a Bullenstein bootstrap that has been already proposed 20 years ago for covariance-based structural equation modeling. And we finally saw, by means of this very small simulation study, that confirmatory composite analysis seems to be able to really distinguish between well-specified and ill-specified, or well-fitting and ill-fitting models, and can help us come closer to the truth. Thank you very much.